Have you ever wondered what keeps a 500-ton airplane safely on the ground when it touches down at full speed, carrying hundreds of passengers, tons of cargo, and the full force of gravity? The secret lies in one of the most overlooked yet most extraordinary pieces of engineering ever created: the landing gear. Today, we take you inside an advanced factory where massive plane landing gears are built from scratch. What you are about to discover is a story of raw steel transforming into one of the most sophisticated safety systems in aviation. Stay tuned, because once you see the level of precision, strength, and hidden science behind these giants of engineering, you'll never look at airplanes the same way again. It all begins with the choice of material. Unlike normal car wheels or bicycle frames, landing gears must withstand forces beyond imagination. When a commercial aircraft lands, the impact shock can exceed hundreds of thousands of pounds of force in just a split second. The material must not only be strong, it must also be resilient, flexible enough to absorb shock, and tough enough to survive thousands of takeoffs and landings over decades of use. Engineers start with a unique type of steel alloy, sometimes combined with titanium, forged under extreme heat and pressure. Inside the factory, massive furnaces roar like dragons, heating chunks of raw steel until they glow white-hot, almost like pieces of the sun trapped in human hands. Workers in protective suits move carefully, as robotic arms lift these molten giants and press them into the rough shape of what will one day become a landing gear strut. From this point, the real transformation begins. Every inch of the landing gear must be machined with microscopic precision. Why? Because a tiny flaw in alignment could spell disaster when an aircraft traveling at 250 kilometers per hour touches down. Imagine a human leg bone, but multiplied to the size of a small building. Now imagine that leg bone needing to bend, absorb shock, and roll smoothly all at the same time. The gear's shock absorber, called an oleo strut, is the heart of the system. This massive cylinder, filled with nitrogen gas and hydraulic fluid, compresses instantly on landing, like a giant cushion, converting brutal impact into a smooth ride for passengers. The machining process of this strut is extraordinary. Using giant lathes, computer-controlled milling machines, and grinding tools, the steel alloy is cut, polished, and hollowed out with a precision measured, not in millimeters, but in microns. Inside the factory, the sound is a mix of grinding wheels, hydraulic pumps, and the rhythmic clank of steel meeting steel. Sparks fly as robotic arms weld gigantic joints, while teams of engineers oversee the process through computer screens. Every step is monitored, logged, and tested, because in aviation there is zero margin for error. Even the bolts used in a landing gear are tested far beyond the loads they will ever face. Some of these bolts are as thick as a man's arm, and yet they must fit with absolute perfection into the gear housing. The wheels themselves are a different story. A commercial aircraft like the Boeing 777 can have landing gear wheels taller than an average human, each capable of holding pressure up to 200 psi, almost 10 times the pressure inside a car tire. To mount these wheels, engineers use hydraulic presses that lock the tires onto rims, which are themselves forged from advanced aluminum alloys. But what happens when all these parts are brought together? This is where the landing gear truly takes shape. In assembly bays that look more like science fiction labs than factories, giant cranes lift the struts, wheels, hydraulic lines, and electronics into place. Workers carefully connect hydraulic pipes, which will later control the extension and retraction of the gear. These pipes must handle pressure strong enough to crush metal instantly. Yet, they must also respond to delicate signals from the cockpit, allowing a pilot to raise or lower the landing gear with a flick of a switch. The integration of electronics is equally vital. Modern landing gears are filled with sensors that monitor pressure, temperature, position, and even wear on the wheels. This information is constantly transmitted to the cockpit and maintenance crews. In the past, landing gears were purely mechanical. Today, they are intelligent systems, part of the nervous system of the airplane. Now comes the most intense part of the process: testing. Every landing gear must prove itself before it can ever touch a runway. The tests are brutal. In giant testing rigs, landing gears are slammed repeatedly with weights equal to the mass of a fully loaded aircraft. They are frozen to Arctic temperatures and then blasted with desert heat. Engineers flood them with water to simulate tropical rainstorms, then blast them with salt spray to mimic years of ocean air corrosion. Some gears are tested until they literally break, just so engineers can study the point of failure. Only after passing all these torture tests can a landing gear earn its place under a real aircraft. One of the most fascinating things about landing gear production is the sheer size of the components. The main gear for a jumbo jet can stand over 6 meters tall, almost like a two-story building. Just moving one from one side of the factory to the other requires special trucks, cranes, and careful choreography. Watching these giants roll silently across the factory floor is like watching steel dinosaurs being guided into life. And yet, despite their size, the precision is breathtaking. Every weld is X-rayed, every joint scanned with ultrasound, every component measured again and again. It is not enough for the gear to be good, it must be flawless. Imagine for a moment what is riding on this flawless engineering. When an aircraft descends toward the runway, passengers look out the window and see the gear deploying. It looks simple, almost casual, as if a set of wheels is just dropping out of the belly of the plane. But hidden in that moment are decades of innovation, millions of hours of engineering, and the silent work of thousands of factory workers and designers. If a single part of that gear fails, the consequences are unthinkable. That is why the landing gear is not just a mechanical system. It is a promise of safety, built with the sweat, knowledge, and dedication of generations of engineers. Finally, when a landing gear is certified, painted, and delivered to the aircraft manufacturer, it becomes part of a machine that defies gravity every single day. Watching a gear being bolted onto a giant airliner is like watching a crown placed on a king. It is the moment when a collection of steel, hydraulics, and electronics becomes the foundation of trust for millions of travelers. And the next time you hear the roar of tires meeting a runway, remember the journey that began with raw steel glowing in a furnace and ended with one of the greatest marvels of engineering holding hundreds of lives safely above the ground. This was the hidden world inside the advanced factories where massive plane landing gears are born. A story of fire and steel, precision and patience, strength and intelligence all coming together to serve one simple purpose: to bring us safely home. And if you enjoyed stepping into this world of engineering wonders, make sure you stay with us for our next journey, because the factories of tomorrow hold even greater secrets waiting to be revealed.